Hello engineers, welcome to the fourth lecture of Analog Fundamental. So, firstly revise that what we covered till now. So we covered that the first part, the first lecture that we discuss about what is the network and what is the circuit. What is the difference between network and circuit? So network and circuit both are designed with the electrical components, electronics components. You have a resistor, capacitor, inductor and you design it. If you have a power rail, it means you have a VDD and VSS and they form the closed path and the current can flow, that it become a circuit. For a network, it is not compulsory to have a power supply. It can be a open source also. There is no any requirement of source. It can be open. So all the circuit become a network, but all network is not a circuit. So this is the way you can define the network and circuit. After this, we discuss about the resistor, capacitor, inductor, and we discuss how the resistor, capacitor, inductor introduced in your layout in a VLSI. So if you have a layout, in a layout you have a metal routing, you are connecting one point to another point, that's why you require a conductor and you are using a metal route. So if you have a metal route, of course you have a seat resistance, and if you have a seat resistance, on the basis of the length and area you can describe you have a resistance. So of course you have a IR drop. What is the voltage? So we will discuss by the Ohm's law. What is the meaning of the Ohm's law and how we can discuss this part. So as per the point of view that you have a layout and you are using a metal routing, that means you have a resistance, you have a potential drop. Where that you are not using a physical resistance. This is present internally, that is called parasitics. Similarly, if you have a two metal and they are parallel to each other, so of course everywhere you have a field outside in a layout, so they will form a capacitance. So of course they have a parasitic capacitance. They are not physical capacitance, but they are present. So they are also degrade your performance in terms of gain. Let you are talking about that Bode plot. You have a DC gain and after some frequency it is decreasing. What is happening? Basically the parasitic capacitance will introduce as per the high frequency and it will decrease your gain. Similarly, if you talk about the inductance is very small because that have a very small value. So we are not talking about the inductance, and we can say that we can eliminate this part. Okay, we only focus on the resistor and capacitor. In second class we started ki okay, we have a resistance, we have a capacitance, but now let's talk about the physical resistance. You have a fixed resistance or you have a resistance that by design by the MOSFET. So MOSFET have a different region, that have a cutoff, that have a linear, have a saturation, that have a threshold. So if you are using a MOSFET in a linear region or a triode region, it behave like a resistor. So you can use a voltage controlled resistor. You can just think in this way. You have an electric vehicle, you have a car, and that is designed by the electric vehicle, by the electric components. Okay, so as per the, you are accelerating your car is moving fast. What is happening? Basically in fuel it is pumping, that engine is too much pumping and that the fuel is burning and you find the speed. But in terms of electric component, as per you accelerate your car, your resistance is decreasing, your current is increasing as your speed is high. So what is happening? Basically you are controlling your resistance so that you find that large amount of current. Similarly, I given one example. In a BTech time we are using a LDR, that is light dependent resistance, and we make the project that you have a sunlight and a solar panel. That solar panel is fixed, but we can move that solar panel on the intensity of the sunlight. So what I am using, I am just using that LDR and find the intensity, and by this intensity it can control, okay, this intensity is good, so it is maintained like this. After that, the intensity that sun is moving, as per that LDR is also find that the intensity it can rotate. So you can find every time the sunlight. So basically this is voltage controlled resistor, that is a tunable resistor. If you are using a fixed resistor, that a fixed resistance, that you have a fixed current. There is no any requirement. If you increase the voltage, then only you can find the large current. But if you have a fixed voltage and fixed resistance, you have a fixed current. But if you have a tunable resistor, you can control your resistor on the basis of the input voltage in a MOSFET. That is called linear region. So in the second lecture, we discuss this part, and we discuss more on that MOSFET is behave like a capacitor also. So in a MOSFET, you have a gate voltage, you have a source, drain and body. If you connect all the source, drain, body with respect of second terminal, and the gate is first terminal, and you have a silicon dioxide in between this, so it become a capacitor. So MOSFET is also behave like a capacitor. MOSFET is act like a resistor. MOSFET is behave like a capacitor also. You can design a MOSFET by the help of source, drain and body is sorted and become a one terminal, and the gate is a different terminal. So voltage control capacitor is also present. So you can store the electric field as per you have a capacitor. Last point, we cannot design an inductor, and that we cannot say that the MOSFET is act like a inductor. We can design an inductor by the help of MOSFET circuits. So you can use a op-amp. By the help of the op-amp, you can design in this way कि V and I have a relation is V is equal to X di by dt. So X become an inductor, because op-amp is just a mathematical tool in analog circuit. So you can convert the circuit in this way by the help of resistor, capacitor and the different things. You can then design the circuit in this way that V is equal to X di by dt, where X is become an inductor. So MOSFET is not act like an inductor because this does not have any turns and does not have any space for the storing the magnetic field. But we can design an inductor by the help of MOSFET that become a circuit. Then we go for the third class. In the third lecture, we discuss about that dependent source and independent source. That is very important. So whenever you talk about the amplification, we cannot amplify by the help of resistor, capacitor, inductor only. We require some another circuit. So how can you convert your circuit? In this way, it will behave like an amplifier. So where we require a dependent source. The dependent source, whenever you talk about the MOS amplifier, that a common source amplifier or common drain amplifier or common gate amplifier or differential amplifier, op-amp, anywhere if you are talking about the amplifier, you are converting your signal into a small signal model, and where you find the dependent source. What is the meaning of dependent source? The dependent source meaning the voltage with respect of the dependency of the voltage or current with respect of any circuit elements. Let you have any current in any circuit, and you can define this voltage or current with respect of any dependent source. And in terms of voltage and current, you can describe into four ways, that is voltage control voltage source, voltage control current source, current control current source, current control voltage source. These are the four types. The voltage control voltage source just like an internal architecture of the op-amp. So you have a difference of input, that Vn1 and Vn2, and you find that you have a dependent source inside the circuit, and that is behave like a voltage control voltage source. The source is voltage and dependency on the input voltage, that is called voltage control voltage source. Op-amp is an example of voltage control voltage source. Voltage control current source, just like a MOSFET. You have an input voltage and you find that GM-VGS. The GM-VGS is behave like a voltage controlled current source. Okay, so this is the way you can describe it. And then we talk about current control current source, current control voltage source. We have a different thing. Okay, so as per the requirement we can. So we have a voltage control current source, voltage control current source, and voltage control voltage source, current control current source, everything we have, and as per the requirement we can. Today's we are going for a Ohm's law, because as per your IC you have a billions of transistor, If you have a billions of transistors, means you have a MOSFETs, and here we are determining the current and voltage in between the path through the MOSFET. So where I am using a Ohm's law, where I am using a KCL and KVL. So KCL and KVL and Ohm's law is very fundamental laws that will help you to determine what is happening inside the circuit. Till now you are discussing about the sources, or you are defining that resistor, capacitor, inductor. Now we are going to that analyze how that current is flowing, what is that value, how can we determine what is the voltage across this element. So here we are going for a KCL, KVL and Ohm's law. So let's start with the Ohm's law. So Ohm's law, that is very basic. I am not going for the 8th class. So describe the Ohm's law, state that something. I am just directly representing in terms of BTech and explaining in this way. It tells us how voltage, current and resistance behave in any path. By the Ohm's law, of course, it is have some condition. It must be have a linear circuit, and it have a physical property just at the constant temperature. You can use Ohm's law. So by the Ohm's law, you can describe how voltage, current and resistor behave in any path, that V is equal to IR. If I am talking about, you have a resistor and we can say that this is the current. So what will be the voltage? The voltage is like V. If the current is entering in any passive element, if the current is entering in any passive element, what is the meaning of passive element? Those are power absorbing or power dissipating. That is called passive element. Resistor, capacitor, inductor, they are the passive elements. So if you have a resistance, the current is entering, that means the first sign is positive and the second sign is negative. So current through this resistance is equal to the voltage across this resistance. Please remember, current through the resistance is equal to the voltage across this resistance, that V is equal to IR. That is represent your Ohm's law. Ohm's law is only valid for a linear circuit. So you can ask in this way, sir, you are saying that resistor is a linear circuit and we can use a V is equal to IR, and you are saying that in a IC you are using a billions of transistor where we have a MOSFET, and MOSFET is a non-linear. So how we can use a Ohm's law in a IC, in a non-linear device? So I am just explaining in this way, okay, you have a diode. Let diode is also a non-linear device. Why? Because the ID versus VD have a graph like this. Or you are talking about the MOSFET, let you have a MOSFET and you have a current relation as ID is directly proportional to VGS minus VTH ka whole square. So of course this is also a non-linear. So how we can relate in terms of Ohm's law? Because Ohm's law is only for a linear circuit. Yes, we can relate that MOSFET and diode and non-linear circuit. Non-linear circuit is very difficult to analyze. Similarly, I can say that ID is equal to IS e की power VBE upon VT, या V diode upon VT. So this is that the diode current. If you are talking about the exponential way, this is very tough to analyze, because you must have a basic understanding of exponential e की power 1, e की power 2, e की power 3, e की power 4. It is very tough to analyze because non-linear circuit is in terms of exponential or square term. But if I am talking about the linear circuit, that you have a current is 2 ampere and the resistance is 2 ohms, so 2 into 2, that is 4 volt. That is a linear path. So for an analyzing purpose, for the calculation, linear is very easy to compare a non-linear circuit. So what we are doing, we are converting a non-linear circuit into a linear form. Just think in this way, okay, you have a non-linear path. You are in hill station. In hill station, if you are looking from the top of that, let you have a drone, And if you are looking at a forest, in this forest you have a road like this. This is a non-linear. But if you land your drone at this point, if the light intensity is near about this part, so it is look like a linear. So that is the form of the small signal model. So when we are talking about the MOSFET is basically a non-linear circuit. But when we are talking about that at exact point, let you have a exact value, you have a some drain current. Let at that the exact point, you have a some X value. At that value of the VGS, if I am changing a small value of delta VGS plus minus delta VGS, it is looking like a small signal model. It is looking like a linear circuit. Then only we can use a Ohm's law. So we can use a Ohm's law, but firstly we convert this circuit into a non-linear to linear. So that's why we are using Ohm's law, KCL and KVL. All these method is valid in IC, because we are converting all these fundamentals into a linear form. So you can relate, okay, anyone can ask, okay, you are saying that Ohm's law is valid for a linear circuit. How you can use in a IC? Because IC you have billions of transistors and the transistor is non-linear. So we can say that, okay, we can think in this way, okay, that you have a MOSFET is non-linear. Let this is graph of ID versus VGS of MOSFET, and you have this is threshold voltage of the MOSFET. Of course this is non-linear, but if I am putting a sim value or the VGS and you find the fixed value of ID, at this point you are finding that the value, if I am changing this value of VGS is very small, this device become a linear. Then only we can use a Ohm's law and we can find very basic way. Of course you require this value at this point. That's why you are using tool. Why tool is required for you? Why we are going for a calculator? So in a calculator we require an exponential way, exponential value e ki power 2, e ki power 3, e ki power 4, because we cannot calculate e ki power 2, e ki power 3. We are not easy to find that e ki power 2, e ki power 3, e ki power 4. So what can we do? We are just finding, okay, we have this value by the help of calculator, by the help of tool. After this, if I am changing a small value, that the circuit become linear, we can make that circuit a linear way and analyze it properly in linear method. That's why Ohm's law is valid for everywhere. That's why you are converting non-linear circuit into a linear circuit. So just think that Ohm's law is not just like V is equal to IR. That is a very broad way you can understand. Why Ohm's law is valid till now? Where that we are talking about the non-linear circuit. Of course Ohm's law is valid here. Okay. So what is the VLSI relevance of the Ohm's law? You can think in this way, that IR drop. From the first class to fourth class, I am always talking about the IR drop. In every class, I am talking about the IR drop. What is the meaning of IR drop? So I am just explaining in this way, okay, you have a supply that is 1 volt and you have a metal, and after the metal you have a block. And by the calculation, by the DRM, design rule manual, or if you are using any technology, of course everywhere we will find the DRM file. In a DRM file you will find that at this temperature, at this value, you will find the seat resistance. On the basis of the seat resistance you can calculate that value of the resistance. So there is a requirement of the DRM file, that you are using a GPDK45 or you are using TSMC Taiwan Semiconductor 45 nanometer technology. So if you are using 45 nanometer technology of the TSMC, you go for the DRM file. In a DRM file, at X temperature, what will be the value of this resistance? So if you are using, let you are using metal 1 or metal 2 or metal 3 as per your requirement, I am using, let this is metal 1. So you can calculate it, what is the value of that resistance. Let the value is 50 ohm and this is 1 volt. So what is happening, that let the current, I am just saying that the current is demanding is let 2 milliampere. The current is going at 2 milliampere. I am assuming that the current is going 2 milliampere. So what is the voltage here? It is very basic there. 2 into 50 is 100 millivolt. And the current is entering in a passive element. This is resistance. The current is entering, so always it is a positive and the second sign is negative. If you have a passive element like resistor, capacitor, inductor, they are passive element. If the current is entering, so that first sign is positive, the second sign is negative. If they are active, the current is entering in a negative terminal. We will discuss when we talk about the active element and passive element, where we are talking about the Telegrams theorem in a power dissipation. We will discuss this part. But for now, okay, you have a metal. If current is entering, so 2 milliampere into 50 become 100 millivolt. I can say that this is 0.1 volt. Yes, milli it becomes 0.1. Okay, so this is 1, this have a drop of 0.1, so of course it is have only a 0.9. So now the voltage is drop at 1 volt to 0.9. The drop is 0.1 here. That is called IR drop. This is called IR drop. So if you are going for a layout designer, if you are interested for a layout design, so we prefer that routing must be very near to each other. You are not using routing in this way. Okay, you have a one point, you have another point, you can't use this route like this. If there is no any requirement of matching. If there is a requirement of matching, you can. But generally we are using this type of routing, not this type of routing. If you are using this type of routing, that much amount of resistance you have, as much drop is here. Let you have a 1 volt here, it is not 0.9, it will be maybe 0.6 volt. That 0.4 volt have a drop because this is linear and the resistance is present, that the length is increasing, resistance is increases. So the drop is increases. So that's why whenever you talk about the layout, I am just saying that that block is connecting and near to each other. Whenever you are designing that architecture, of course, when you talk about the analog circuit flow, analog circuit designing flow, yeah, ASIC design flow, you find that first one is design specification. A market engineer or designer or the requirement will decide that what is the design specification you have, what is the power requirement, what is the frequencies requirement, what is the technologies requirement. Everything you must know if you are designing any project. After this, you are going for a design architecture. In a design architecture, you decide it where I am using the differential pair, where I am using ADC, where I am using a digital processing unit, where I am using IO blocks. Everywhere you must design in this way. Of course, these are the designers, the designing block. They are not circuit, they are the blocks only, that is designed by the 14 to 15 or 10-year experienced persons. They must have a too much idea, okay, what will happen when you are going in this way. So there's a design architecture design in this way. So whenever, okay, you have a block like this, you have a block, you have a B block, you can't design this way. If you are designing in this way, you will find that you have a lot of IR drop is here, that they have a Ohm's law here. And if you have a drop, you have a drop of 0.4 volt. So this is one of the way you can use that Ohm's law, that is IR drop. What is the meaning of power dissipation? So if you know the voltage, if you know the current, you can use basically a basic that V into I, that is power dissipation. If you know the voltage across the any element and you know the current through this element, you can determine V into I and you can determine what is the power dissipation. Similarly, if you have only current, so you can use I square into R. If you have only voltage across the resistance, you can use V square by R. So if you have a basic understanding of voltage and current, you can determine what is power across that element by the help of V into I and I square into R or V square by R. So that is also related with the basic Ohm's law. Of course, this is non-linear. Don't think in this way, okay, sir, the power dissipation is non-linear. Why you are talking about this? You can determine voltage and current by the help of Ohm's law. If you have a voltage and current, you can use that P is equal to V into I. Let's talk about RC delay. If you have a resistor, if you have a voltage, let you have a voltage here and you have a current, let this is X and this is Y. So if you have a voltage, if you know the voltage, if you know the current, you can determine is R is equal to Y by X. If you know the resistor, you can determine what is the time constant, how fast capacitor is charging, how fast capacitor is discharging. So you have a capacitor, you have a routing. By the routing, you can determine what is the resistance. By the help of V by I, you can determine is what is the resistance. On the basis of the resistance, you can describe what is the time constant. How capacitor is charging and how capacitor is discharged. So this is also related to your RC delay. Okay, so this is the way you can analyze your part. Now I am going for a Kirchhoff current law. So Kirchhoff current law is very, very important. So if you know Ohm's law, you can use by the help of Kirchhoff current law. If you are using Ohm's law, you can determine the current and voltage through that any branch. So what is the Kirchhoff current law say? That Kirchhoff current law state that sum of current entering a node is equal to the sum of current leaving a node. What is the meaning of node? In last class we discussed the node, a point, a junction at which two or more than two elements are connected, that is called node. And in the node you have a voltage, the voltage always with respect of any reference node. So a node where that entering current is equal to leaving current, that is called Kirchhoff current law. Sum of current entering a node equal to the sum of current leaving at a node, that is called Kirchhoff current law. I am saying that okay, we have a node, let that at this node, this is I1, this is I2, this is I3, this is something, okay. I am saying that this is I1, this is I2, this is I3, this is I4, this is I5 and this is I6. So at this node, what is that KCL? If you are using a KCL, you can determine it any current. If you know all these current, let you have a understanding of I1, I2, I3, I4, I5, you can determine it I6 by the help of KCL. How? Just simply say that what is the entering current? The entering current is I1. What is the entering current? That is I4. What is the entering current? That is I5. What is the entering current? I6. Entering current means what? Towards the node, the current is entering. Towards the node, I1 is entering towards the node, I6 is entering, I5 is entering, I4 is entering. The entering current is equal to leaving current. What is the leaving current? That is I2 and I3. So I1 plus I4 plus I5 plus I6 is equal to I2 plus I3. That is called KCL, that Kirchhoff current law. Kirchhoff current law states that the entering current at a node is equal to the leaving current towards the node. That is called KCL. And that is very useful to determine is the current. Let I am giving a one basic example. If you are interested for a MOSFET, let you have a CMOS inverter. Okay, I am giving these examples because you can relate it. You can't think this is very boring that we know about it. Okay, if you know about it, just think about this. Okay, you have some V in one and you have this capacitor or load. Just relate this concept in this CMOS inverter. You have some V in you have a some I1. For this V in you have a some I2. What is X? So if I1, I2 and I3 is in this way, at this node what is happening? The I1 current is entering, I2 plus Ix is leaving. So in this way you can explain how that capacitor is charging, how capacitor is discharging. If I1 is greater than I2, so Ix have a some current. The first case, I1 is greater than I2, so I1 minus I2 is your X, and that is positive value. Means this have a current, that current is going towards the capacitor is charging. In the second case, if I2 is greater than I1, so what is happened? The I2 current is high. So what will be that? I1 minus I2 is equal to X, where I2 is higher. That means this is negative sign. This is negative sign means X is not in this direction. X have a different direction. So that the meaning capacitor is discharging. So this is the way you can explain by the help of KCL only I can explain this part. There is no any requirement of rocket science. There is a only basic requirement, that KCL. So the current is entering and the distributing in two parts, I2 and Ix. I am assuming that the direction like this. If I1 greater than I2, so I1 minus I2 will be your X. And where you can determine that capacitor is charging by the help of X value. Similarly, if I2 is higher compared to I1, so now X will provide the current. Why? Because I2 is higher, so compared to I1, so remaining current will provided by this capacitor. Means the capacitor is discharging, means capacitor will provide the current to this branch. So just relate this basic KCL to this part. I am just explaining CMOS inverter, you can take anything. Just think about the common source amplifier, common drain amplifier, op-amp, differential amplifier, everywhere. You just use basic definition of KCL and you can explain how the current is going on in the circuit. So let's start with the basic numerical. So you can practice on that. Okay, how you can determine I1, I2, I3. Basically the main goal is analog circuit. But for the main goal, you must have a basic understanding how you can understand that current is flowing there. Then only you can analyze in a big circuit. That's why network fundamental is required for you. Let's talk about this circuit. You have a minus 8 ampere, the current is moving in this way, I1, I2 and this is present. Let's figure out what is I1 and I2. You can take any node, okay. Where is node? This is the node. This is the node. This is the node. Where two or more than two elements are connected, that is called node. It have a 2 point, that is simple node and principal node. When two elements are connected, that is called simple node. More than two elements are connected, that the node is become a principal node. So I am not going for simple and principal, I am just connecting the node only. And let this is, I am assuming this node, I can assume this node, I can assume this node. It depends on you. So if you are assuming this node, what have the problem? At this node, you have a current, you don't know what is I1, you don't know I2, you don't know, you have an understanding of 4 ampere. So you have this current, you have this current, but you don't know what the I1 and I2. So in one equation, you will find a 2 unknown. So I prefer to that node where you have only one unknown and remaining will known. I am talking about this node. You have this current, you have this current, but you don't know I1. In one equation you can find it. So let's talk about this node. The leaving current is minus 8 ampere. The sign is same. I am not changing the sign, that minus 8 is in this direction, so make it plus 8. I am not going in this way. I am just saying that okay, the leaving current is minus 8. The leaving current is minus 6. is equal to entering current, leaving current, entering current. That is your I1. So I1 become what? That is minus 14. 8 plus 6 become 14 and the sign is minus to minus 14. So I1 have a direction is, if you are looking of this direction, it is minus 14. If you are looking this direction, this is plus 14. If anyone asking about this direction, so this is plus 14. If I1 is asking in this direction, this is minus 14. Let's talk about this point. At this node, I2 is entering, I6 minus 6 ampere is entering and 4 ampere is leaving. I2 is entering, minus 6 ampere is entering and 4 ampere is leaving. So I2 is 10 ampere. So the direction is I2 and it is positive. So there is no meaning. If anyone asking about this direction of I2, you can say this is minus 10. You can check it also. Okay, if you are taking this node, you can explain, okay, I2 is correct or not. We know that I2 is 10, but let's prove it. So why? At this node, minus 8 ampere is entering, 14 ampere is entering, 4 ampere is entering and I2 is leaving. So what is I2? 14 plus 4 is 18, 18 minus 8 is 10. So this is 10 ampere. Just check it, the answer is correct or not. KCL is valid for everywhere. If KCL is not valid in your circuit, that means you are doing something wrong or the circuit is wrong. If you find that KCL is not valid, that means circuit does not exist. You can write in this one line, the circuit does not exist. If you solve some questions and where that current is not feasible in this way and you are not determining and that entering current is not equal to leaving current, that you can directly write it, the circuit does not exist. But of course circuit does not exist. Before that, just check it again. So this is the way you can analyze the circuit and the basic definition by the help of KCL. Okay, take your time, take a 2 minutes and solve it. You have this circuit where you have a 5 ampere, 1 ampere, I1, 6 ampere, 4 ampere, 2 ampere, 7 ampere, I2 and I3. Just determine it, what is I1, what is I2 and what is I3. Take your time, take your 2 minutes and solve it. This is very simple there. Just solve it. How can you determine it, what is I1, what is I2 and what is I3? I am waiting for your answer. Okay, so let's try this. How can you solve with I1, I2 and I3? You have this node, you have this node, you have this node, you have as many nodes you have. You have a node. You have a node is here, you have a node is here, you have a node, you have a node, you have a node. So I am putting, okay, at this node what is happening? This 1 ampere is leaving, this 6 ampere is leaving, that I1 is entering. So I can say that, okay, at this node the entering current is I1 and the leaving current is 1 ampere and 6 ampere. 1 ampere and 6 ampere. So this has become a 7 ampere. I1 is 7 ampere. Okay, this is okay that I1 is here. Let's talk about I2. So I2 is what? If you talk about this node, here you have a 4 ampere, you don't know about the I3, you know about the 7 ampere. So I will prefer that node only where we have a multiple, we have a many answers, we have a many values. So if you are talking about this node, so you have a 6 ampere, you have a 7 ampere, you have I2. At this node only you have one unknown. So at this node the 6 ampere is entering, is equal to 7 is leaving and I2 is leaving. At 6 ampere is entering, I2 is leaving, 7 ampere is leaving. You are understanding what is the meaning of entering. Towards the current is towards the node is entering. Away from the node it is leaving. So towards this is 6 ampere, leaving is I2 and 7. So what is I2? So I2 is minus 1 ampere. So you have a I1 value, you have a I2 value, just determine what is I3. So let I am using this node. This is 4 ampere is leaving, I2 is entering and I3 is entering. So 4 ampere is equal to I2 is entering and I3 is entering at this node. So you know I2, so 4 minus 1 plus I3, so I3 is equal to 5 ampere. Okay, if you want to check it, you can check by this node. 7 ampere is entering, 2 ampere is leaving, so remaining current is 5 ampere. This is correct. The answer is correct. You are determining I1 by the help of 1 and 6. Let's figure out how we can determine by this node. 5 is entering, 2 is entering, I1 is leaving. 5 plus 2 is 7. That is I1 is 7 ampere. You can check it. So there is not only this node. If I am assuming this node, there is not the only way you can solve the KCL at this node. You can solve by the different node also. But the answer is correct. The beauty of the network is this. You can solve any way. You can use superposition, you can use Thevenin, you can use KCL, you can use nodal analysis, you can use Teligans, you can use source transformation. Anything you can use. But the answer is one only. That the answer is I1 is equal to 7 ampere if you are using this node or this node or this node or any node. You can use different way, but the correct answer is only one. That is the beauty of the network. Let's talk about this, where I am using a dependent source. I am introducing the dependent source here and determine what is that V out, V0 or V out, anything you can say that. Okay. So there is no any, I am using very basic large thing. Okay, you have a this, okay, not like this. Just use a basic, very basic fundas, that is KCL. Let's talk about this node. The 2I0 is entering and 4 ampere is entering. 2I0, 4I0, sorry, 4 ampere, 2I0, 4 ampere is entering, the leaving current is 3I0. So I can write it in at this node that the equation is 2I0 plus 4 is equal to 3I0. One line answer. 2I0, 4, 3I0. It may be difficult in looking, but it is easy once you go for the KCL. So 2I0 plus 4 is equal to 3I0. 2I0 plus 4 is equal to 3I0. What is I0? I0 is equal to 4. 3I0 minus 2I0 become I0. I0 is equal to 4. So that current, so what is V0? V0 is 3I0 into 4, because this is not I0 into 4. This is 3I0 into 4. V0 is the current through 4 ohm, that is 3I0. So V0 is what? V0 is equal to 4 into the current is 3I0. So this is 12 into what is I0? That is 4. 48 volt. Just check it. This is correct. 2I0 plus 4, this is equal to 3I0. So I0 become 4. So the current is 4 into 3, that is 12. And V0 is 12 into 4, it become a 48. The voltage is 48. So V0 is 48. So this is the way you can solve the basic circuit of by the help of KCL. And these if you are good in these type of circuit, you can analyze big circuits also. Let's talk about Kirchhoff voltage law. So as per that KCL, that the Kirchhoff current law is saying that the entering current is equal to leaving current. Similarly, Kirchhoff voltage law, what is saying that it is state that sum of voltage around any closed loop equal to 0. The algebraic sum of voltage in around a closed loop equal to 0. In a loop, if you're talking about the algebraic sum of voltage, what is the meaning of algebraic sum? Algebraic means the sign. Okay, that if you are connect all these voltage and connect it and solve in a way that algebraic sum, that the direction of the voltage and with the sign of this, and you find that the overall voltage is 0. In a state that the sum of voltage around any closed loop equal to 0, the algebraic sum of voltage in any closed loop equal to 0. That is called KVL, Kirchhoff voltage law. Kirchhoff voltage law and Kirchhoff current law is the backbone of the network or backbone of analog circuit designing. If you are interested of any analog circuit design or PCB design or embedded system, if you are interested for a back-end designing, these are the way you can analyze, okay, how that current is flowing, what amount of current is flowing here, by the help of KCL and KVL only. So I am just explaining that how you can determine voltage. Let I have a element, and how can you use a Kirchhoff voltage law and Kirchhoff current law or Kirchhoff. Okay, we know that how can we use a Kirchhoff voltage law. This is V1, this is V2, this is V3. Of course, you have a voltage and the voltage have a sign. If you have a voltage, you have a sign, you have a current, that you have a direction. Current hold the direction, voltage hold the sign. So you have a voltage, you have a sign. Kirchhoff voltage law is that if you have a closed path, if you are using a Kirchhoff voltage, the algebraic sum of voltage in a closed loop equal to 0. What is the meaning of algebraic sum? I am saying that this is the loop, this is a circuit I am using in this path, in this way. So the first sign is negative, the first sign is negative, the first sign is positive. I am using a very basic method. The first sign is negative, that is minus V1. The first sign is negative, that is minus V2. The first sign is negative positive, that is V3, and equal to 0. So this is V3 is equal to V1 plus V2. Kirchhoff voltage law say that the algebraic sum of voltage in a closed loop equal to 0. So of course you must have a Kirchhoff voltage law only in closed loop. So once you have a closed loop, you just use a basic in a clockwise direction or anti-clockwise direction, just move in this way and you can determine, okay, the first sign. Some of that students are using that negative to positive, they are increasing, so it is positive sign. You can use in this way also. If you are interested, that negative to positive, that is plus V1, negative to positive, that is plus V2, positive to negative matter decreases, that is minus V3 is equal to 0. This is also V1 plus V2 is equal to V3. So the Kirchhoff voltage law you are using to negative to positive for increment of the first sign, they both are same, the value is same, there is no any changes here. Okay, so this is the way you can determine a Kirchhoff voltage law. If you have a known value of V1 and V2, you can determine V3. If you have a V1, you have a V3, you can determine V2. If you have a V3 and V2, you can determine V1. So let's solve some question on this. So you can use the KCL and you can use that KVL properties. So the first numerical we have a V1, we have a some voltage, we have a some voltage, we have a some voltage, we have a V2. Just determine what is V1 and what is V2. Just solve it. Take your 2 minutes and solve it. Just try to solve it. What is V1 and what is V2 for this question, where I am using a basic KVL. So you have a V1, you have a 1 volt, you have a 5 volt, you have a 2 volt, you have a V2. Just determine it. Take your time and solve it, because if you solve it, you have a confidence. If you're confident, you can solve the analog circuit also. Network is very easy there. Network is one line. Mathematics can be more than one line. So just solve it. How can you determine V1 and V2? So let's solve it. Okay. So I am using, if you are using this loop, or I can change that color. This is the loop. Here you have V1, you have 1 volt, you have 5 volt. The loop can be this, the loop can be this, the loop can be this. A smaller one or bigger one, it depends on you. If I am using the first loop, that this is a first loop, this is a second loop, and this is a third loop, the bigger one. If you are using a first loop, you have a first sign is negative, the first sign is positive, the first sign is positive. So this is minus V1 plus 1 plus 5 equal to 0. So V1 is equal to 6 volt. If I am using a second loop, in the second loop, if I am using the second loop, so just focus it here. What is happening if I am using a second loop? For this second loop, this is a negative, the first sign. For a first loop, it will be a positive because the direction is going in this way. This is positive. But if you are looking the second loop, the process, the clockwise in this way, the first sign is negative. This is the first sign. This is the first sign. So this is minus 5 plus 2 plus V2 is equal to 0. So V2 is equal to 3 volt. Okay, if you want, you can check it also. Okay, you have a value of V1, you have a value of V2. Let's check it and determine it, so that the algebraic sum of voltage is equal to 0 or not. Just check it. You have a V1, you have a V2. I am using a bigger loop. If I am using the bigger loop, that is the first sign is minus V1 plus and plus. So I am writing minus V1 plus 1 plus 2 plus V2 is equal to 0. V1 is 6, so this is minus 6 plus 1 plus 2, and what is V2? That is 3. Just check it. Minus 6 plus 3 plus 2 plus 1 equal to 0. The algebraic sum of voltage in a loop equal to 0. So you can prove it. This is the correct answer. 3 plus 2 plus 1 is 6. 6 minus 6 is 0. So this is the way you can solve that basic KVL questions. Now you have a second question on the KVL. Take your time and solve it. Okay. Yes. Just solve it. What is happening here? You have this question. You are determining V1, V2, and V3. Basic, that KVL. Okay. You can use a KVL. So you can solve this loop. If you are solving this loop, just analyze it. If you are taking this loop, what will happen? You know this value, you know this value, you know this value, you don't know about the V1. If you are using this loop, this element, this element, this element, and this element voltage will require. You know this voltage, you know this voltage, you know this voltage, you don't know about the V1, you can determine in one line. Just solve it. This is minus, this is minus, this is plus, this is plus. Just solve it. This is minus 40, this is minus 50, this is plus 20, and this is plus V1. Just recheck. Minus 40, minus 50 plus 20 plus V1. So V1 is equal to what? 90 minus 20. It becomes 70 volt. V1 is 70 volt. If you are using this loop, so you know V1 but you don't know V2, you don't know V3. There is a two unknown. So I am not using this loop at this time. But if you are using this loop, so what will happen? You know this voltage, you know this element voltage, you don't know V2. By this loop you can determine it. Of course this is one of the late loop, this is also one loop because this is a closed path. So if you are using this loop, so what is happened? This is first sign, this is first sign of this, and this is first sign. So this is minus 20 plus 30 and minus V2 is equal to 0. So V2 is equal to 10 volt. So this is minus V2 minus 20 plus 30. So V2 become a 10 volt. So if you know V1, if you know V2, you can determine it V3 by this loop. So you know the first sign is negative, the first sign is positive. For this loop, for this type of loop, this is first sign negative, the first sign is positive, the first sign is positive. So this is minus V1 plus V2 plus V3 is equal to 0. So V1 is what? That is 70 volt minus 70. V2 is 10. This is V3. So V3 is equal to 60 volt. So you have that type of value. Okay, if you want, you can check it. Okay, that this is your call. Okay, if I want to check this is correct or not. Okay, so you can check it. I am using this loop, that I am using that bigger loop, that this part to this part to this part to this part to this. This is also a loop. If you are using this loop, that this is a first sign is negative, first sign is negative, first sign is positive, first sign is positive. So this is minus 40 minus 50 plus 30 plus V3 is equal to 0. What is V3? That is 60. Okay. So this is minus 90 plus 30 plus 60 equal to 0. Just check it. Minus 90, 30 plus 60 is 90. This is correct. You can take any loop. Okay, you can want this loop, if you want this loop. It depends on you. If you know that V1, V2, V3, of course, for determining V1, V2, V3, I am using the loop in this way, where we have a one unknown and we have a known values is higher. So that's why I am using the first loop, and then I am using this loop and then loop. Okay. You can solve anyway. There is not any restriction ki okay, I am solving by this only. No. You can solve by any way. But the answer is V1 is equal to 70, V2 is equal to 10 and V3 is equal to 60. That is the correct. Process can be anything, but the answer is correct. Okay, let's talk about the third question of that. Okay, let's talk about this question. Take your time and find it. What is Vx and Ir? Where I am using a dependent source. Now I am introducing a dependent source. Till now I am using only a independent source, or you have an element voltage. Now I am first introducing the dependent source. You have a dependent source. Let's talk about this part. So the dependent source is also like this. Of course, the dependent source means dependency of this. You have a 3Ix. So this is a voltage source and the dependency on the current. The current control voltage source. The current is here. This is a dependent source. Dependent source always represent in terms of diamond shape. So this is current control voltage source. Source is voltage and dependency by the help of this current Ix. This Ix will decide what is that voltage value of this dependent voltage. So let's try to find it. So if you are using this loop, this is minus 10, this is plus Vx, this is plus 4, you can determine in one line Vx. So this is minus 10, this is minus 10, and this is plus Vx, and this is plus 4 is equal to 0. So Vx is equal to what? 6 volt. Vx is equal to 6 volt. Minus 10 plus Vx plus 4. You can determine it, what is Vx. Okay. Next, I have a voltage here, I have a voltage here, I am just finding what is that Ix, because we don't know what is that resistance. If you know the resistance, you can determine its current. If you know the resistance, of course you have a 1 volt, you can determine what is the current. But here I am not knowing about the resistance, so I can determine in this loop. By this loop you have a, this is the first sign, this is the first sign, this is the first sign. So this is minus 1 plus 16 plus 3 Ix is equal to 0. So this is Ix is equal to what? That is minus 15 upon 3. That is minus 5 ampere. So Vx is 6 volt and Ix is minus 5. Okay. If you want, you can solve by the bigger loop also. If you are interested, you can determine it. Okay. You have a value of V1. You can use the bigger one loop. This is minus 10. Of course, this is plus, this is plus, this is plus, and this is plus. So this is minus 10. This is plus Vx. Vx is 6 plus 16 plus 3. Ix is equal to 0. Minus 10 plus Vx plus 16 plus 3 Ix. What is happening? Ix is equal to, that is 16 plus 6 is what? That is 22. 22 minus 22 minus 10, it becomes 12. So this is minus 12 upon 3. This is minus 4 ampere. Why this is happening? If you are looking by the bigger loop, you have a Ix is different. If you are using this loop, it have a different. Okay, so just check it. Minus 10 plus Vx. Okay, this is plus 1. It is not plus 4. That's why. Okay. Okay, this is not 4 volt. It is 1 volt. So that's why this is Vx is 9. Okay, let's book it. Take it. This is 4 volt. Okay, I am just changing this value. This is 4 volt. If this is 4, so minus 10 plus Vx plus 4. So it is what? Vx is equal to 6 volt. If you are using this, this is also become a 4 volt. Okay, I am just checking that. Okay, this is minus 4 by the second loop. This is minus 4 plus 16 and this. So this is become a minus 4 plus 16 is minus 12. Okay, and this is become a minus 4 ampere. Okay, it's up to. Oh, okay. Now it is correct. Okay, in the place of 1 volt, I use a 4 volt. So if you are using a 4 volt, the answer is correct. Okay. So there is a basic mistakes. Okay, basic mistake is here. Okay, so that the process is this. Okay, you can analyze the circuit. Okay. So this is the way. Now let's talk about that last question you have. In this, you are determining what is V1, what is V2, and what is V3. Okay, this is also a very good question. where you have a V1, V2, V3. It can be look like a difficult, but it is not difficult here. It is very easy. If you are using this loop, if you don't know the parallel voltage or parallel circuit, so I am using this KVL. If you know the parallel, in a parallel voltage is same, so V3 and 10 are same. If you don't know, you just use a basic KVL. If you are using this loop, this is a first sign, this is a first sign, so this is minus V3 and this is plus 10. So V3 is equal to 10 volt. This is one line, you know V3. If you know V3, you can use this loop. This is first sign, this is first sign, this is first sign. So plus V2 plus V3 plus 12 is equal to 0. V2 is equal to, this is V3 is 10, 10 plus 12 is 22, this is minus 22. V2 is minus 22. Okay. If you talk about the bigger loop, you can solve this. V1 minus 24 plus V1 plus 10 plus 20. So this is minus 24 plus V1 plus 10 and plus 12 is equal to 0. You can solve in a one line, that is minus 24, this is plus 22, so V1 is equal to 2 volt. This is the way you can solve it. Okay. If you are confused here, okay, why I am taking this much loop, you can take the smaller loop also. You can take this loop also. So if you are taking this, so this is minus, this is plus, and this is minus. So I am using, okay, this is minus 24 plus V1 minus V2. This is also one loop. So you know what is V2, this is minus 22. So this is minus 24 plus V1 minus 22 and plus 2 is become at plus 22 is equal to 0. V1 is 2 volt. You can check it. Okay. So if you are not doing a mistake in calculation, the answer will be same. Okay. So this is the way that you have a basic understanding of KCL and KVL. If you know the KCL and KVL, you can analyze, okay, this is the basic network I am using, but this will help you to bias your circuit. Just take a basic example, okay, I am increasing your knowledge that I have a common source amplifier and I am using this resistance graph. If you know the network, you can determine this voltage in a one line. You can analyze this voltage in a one line. Otherwise, if you don't know the network, it will be tough for you. That's why KCL and KVL is important. Okay, so just explain your data. Of course, once you know these basic parts, this basic question, these questions will help you in analog circuit design. When you design a more circuit, when you analyzing the circuit, you know that what is the op-amp circuit. But if you are going for a op-amp circuit, you have a basic understanding of current, how the current is flowing, how the differential amplifier is working, what is the tail current, how the MOSFET is working, the tail MOSFET. So you must have a basic understanding where I am using a KCL and KVL. Okay. So these are the basic parts, basic question. Please work on it. You can use any book. If you have any question, please message on or share our questions on the comment. Please solve as many questions you can solve it, and then after we will solve going for a R equivalent based question, where that is very important for R equivalent. So for now, thank you so much everyone. We will continue tomorrow also and day after tomorrow also. Thank you dear. Thank you.